Hi students, today I will discuss thermodynamics part 2. I already uploaded part 1, right? Please, if you did not watch, no, please watch the part 1 and come back to the part 2. In part 1, we discussed first law of thermodynamics and also the formula, right? Delta Q is equals to delta U plus delta W. What all the formulas of delta Q, delta U and how to calculate the total work done onto this. In this part 2, we will discuss a different process. So, how we are going to change the state of a gas, no, right? So, different process, no, we are going to discuss in the second part. Isobaric process. Isobaric process. What is this isobaric process? Iso means same, baric means bar is a unit of pressure. So, therefore, here iso means same, that means bar is a unit of pressure, no. So, therefore, throughout this process we are taking like a pressure is going to be remains constant. So, pressure is constant means change in pressure it will be equal to 0. Therefore, change in pressure it will be equal to 0. Right? Pressure is constant, no? So, that means if you want to make this pressure to be constant here, so therefore, here you have to use one piston, therefore, this piston, no? So, should be like a massless piston, no? And also frictionless piston. Why? Because if you want to make the pressure to be constant, because if you are supplying the heat, so maybe it will increase the pressure. To decrease the pressure, no, volume should expand onto this. So, therefore, here you have to consider like a massless piston and a frictionless piston also. You are understanding? So, massless and frictionless now. Clear? So, isobaric process, pressure it will be going to be constant onto this. So, how much amount of heat energy we are going to supply now? This will be at constant pressure. So, therefore, NCP into delta T. Cp into delta T. Clear? So, we can write down first law of thermodynamics in this one. No? What is the first law of thermodynamics? We are supplying the heat energy. So, delta Q at constant pressure, it will be equal to utilizing this energy. So, increasing internal energy and also it is doing some amount of work. How much work is done now? Throughout this process, pressure will be constant, no? So, you can write it as delta Q at constant pressure, it will be equal to delta U plus therefore P into delta V. So, this it will be the amount of heat energy supplied. Here one simple some simple derivation, no, we can do it. We already studied, that is Mayer's relation, no, in our part 1 or kinetic theory of gases, no. So, we can derive it, very simple. What is this delta Q now? So, what you can write it now? Delta Q is nothing but a delta Q of a constant pressure, no. So, that is nothing but a NCP into delta T plus therefore, internal energy we studied, no, NCV into delta T plus P into delta V, therefore, PV is equals to nRT. So, therefore, P into delta V is equals to nR into delta T. Therefore, I can rewrite it as nR into delta T. So, at constant temperature, number of moles, you can N into delta T get taken common. So, Cp is equals to Cv plus R. So, that means Cp minus Cv is equals to R. This is our Mayer's relation, which you already used in our kinetic theory of gases. Okay. So, here this is most important, no, how much amount of heat energy we are supplying onto this. So, here in isobaric process, pressure is constant. Pressure is constant. That means pressure is constant means what will happen now? So, PV is equals to therefore nRT, pressure is constant, no, V is equals to nR by P therefore into T. Therefore, here volume is directly proportional to the temperature, absolute temperature. This is nothing but a Charles law. Charles law is nothing but isobaric process. This also we did in kinetic theory of gases in part 1, right? So, please check out that video also, right? Here we can draw the graphs here, no? Therefore, V and T. So, how it will be the graph now? The relation onto this. Therefore, it will be a straight line. So, passing through the origin onto this. Clear? Right? We can solve one problem here. So, here here no, therefore, here Vt graph, here it is Vt graph, no, therefore, here there is a two graphs it will be given now here. So, this is one state and this is another one now, therefore, this is A gas and this is B gas. So, this is volume temperature graph, no. So, we want to calculate, okay, which is having more pressure. pressure of gas A or pressure of gas B, therefore we want to calculate. Here you try to observe, this is nothing but a slope here. So slope is inversely proportional to the P. That means who is having greater slope, no, that it will be having so less amount of pressure. So among this one now, therefore this steepness is very small, the steepness of B is more. So slope of B is more than A, so therefore, but it is inversely proportional, no. So therefore pressure of A gas, it will be greater than pressure of B gas. So these type of questions also you can expect it. Okay. So now, so here this is your isobaric process, no, right. Now what is the amount of work done now? How to calculate the work done in this one now, in this process? So we can calculate the work done. So work done is a pressure is constant, no. So work done we can write it as delta W, therefore pressure is in nothing but a change in volume. Therefore P into V final minus V initial. This is your work done formula. So in a isobaric process. Clear? So now, so we'll see one more process, no, that is nothing but a isochoric process. Isochoric. What is isochoric process now? Iso means same, choric means like a volume, right? So here in the isochoric process, volume is going to be kept constant. When volume is kept constant, change in volume will be 0. When change in volume is 0, so what will happen now? When change in volume is 0, so volume is not changing, work is not done onto this now. Therefore, amount of work done is also equal to 0. That means if you want to have isochoric process, how the system should be there now? This system, so it should be having, so here this it should be like a fixed piston now. So this piston should not able to move onto this. Therefore, we should not change the volume, no. So in this situation, if volume is not done, volume is not changed onto this, no. Whatever the heat energy we are supplying, so the total energy weight is gone now. It is utilizing to increase in the internal energy. So work done is 0. So you can write down first law of thermodynamics, no. So what is that first law of thermodynamics? Delta Q, it will be equal to delta U. So it constant volume. Clear? So this is amount of heat energy, whatever the heat energy is given is completely utilized by the gas to increase its internal energy. So if you are supplying the heat energy, so therefore temperature will increase. If you are decreasing, taking out the heat energy, so temperature will be decreased, internal energy will be decreased. Clear? So in this way you can calculate it now. Therefore, so you can calculate amount of heat energy is given, you can calculate it now. That is nothing but a NCV into delta T. Clear? So volume is constant. So what will be the equation here now? So equation, so PV is equals to nRT, volume is constant, P is equals to nR by therefore V into therefore T. Therefore here pressure is directly proportional to the temperature. This is nothing but a pressure law. Clear? So this is a pressure law. So what will be the graph here now? So what you can write it now? Therefore pressure and temperature variation, so is exactly the same. So like we drawn, so this is passing through the origin. Again you can do like similarly next question, previous question onto this one, no? Their slope is inversely proportional to the volume. So whose slope is more, so that volume is lesser onto this one. Therefore slope is inversely proportional to its volume onto this. Clear? So this is so work is not said to be done now. Therefore here this is about isochoric process now. Clear? So we'll study one is isothermal process. So very important process, no. So isothermal means what? Iso means same, thermal means temperature. Therefore throughout this process temperature is going to be constant. So therefore delta T, it will be equal to 0. Change in temperature will be 0. If change in temperature is 0, so what happened to the internal energy? So internal energy, change in internal energy also will be 0. But internal energy will be constant. Internal energy is constant, but change in internal energy will be 0 onto this. That means temperature should not be, either it should raises or it should not be decrease. So therefore, if it is, see anything if you are doing very faster, so therefore temperature will change onto this unknown. Therefore, if you do not want to change the temperature. So what we should have? We should make it very slow process onto this one. Therefore, so here, so this isothermal process is a very slow process, very slow process. Clear? So isothermal process now. Therefore, it is a slow process on this. So here what happened now? Here what will be we can write down first law of thermodynamics, no? So we can write down delta Q is equals to delta U is 0. So therefore delta W. That means, so what does it mean now? Therefore, so whatever the heat energy we are giving, the total heat energy is utilized to do the work. Therefore, it is completely utilizing to do the work. Therefore, the system is not taking any energy. So that means its specific heat should be how much now? So specific heat, what is the formula? Delta Q by N into delta T. So delta T is 0. That means specific heat should be infinite. That means you have to select one system, the system that is the material which you have to take it, no? Whose specific heat is infinity. So specific heat is infinity means what? We have to give infinite amount of energy to raise 1 degree rise in temperature now. So that type of substance you have to take it, no? So that the substance will never get heated up. So that what happened to that heat energy is given now? That heat energy will be converted into like a amount of work done onto this. Clear? But never exist like this, no? So therefore, whatever the heat energy supplied here, so it will be utilized to do the only work done on this. Now we want to calculate how much amount of work done in this process, no? So first of all, you have to go for equation of state. So therefore, what is this one now? Here temperature is constant. We know that PV is equals to nRT. This it will be equal to constant. Therefore, pressure is inversely proportional to the volume. We studied already. This is nothing but a Boyle's law. Clear? So RPV is equals to constant. So the variation, how you can draw it now? So these graphs, right? Here the pressure, no? Here it will be the volume. How the graph it will be? How the variation will be? It is inversely proportional. It is inversely proportional means like this. So therefore temperature T1. So so if you write down the same gas at different temperature, no? So therefore a temperature T2. If temperature is increasing, pressure and this one it will also increases, no? So therefore isotherm will be shifted away onto this. T2 is greater than T1. Clear? So if we want to calculate the slope of this, what will be the slope now? Slope. Here, so slope means what? You have to draw a tangent here. So how to calculate the slope of these are called isotherms. Slope means change in value. Therefore, dP by dV we want to calculate. So how this slope can be calculated? You take this equation now. Therefore, you can do the differentiation of this. What will get differentiation now? So P into dV, U into V derivative, V into V derivative. Therefore, it will be equal to 0. So from this one now, so you can calculate dP by dV. So taken now, therefore you will get it as minus P by V. This is the slope of isotherm curve. Minus is nothing but it is a negative slope here. Clear? So now, so we can write down, we can calculate what will be the work done or area under the isotherm curve. So work done in isothermal process. This is important, no? Work done in isothermal process. Right. What is the work done now? Or area under the isotherm curve. So work done, what is the formula? You can write it now. Integral P dV. So but we know that PV is equals to nRT. So here, okay. So here P I can write it as P is equals to nRT by V. I will substitute here now. So therefore it is V1 to V2. I can substitute here now P value, that is nothing but a nRT by therefore V into dV, therefore V1 to V2. This nRT temperature is also constant here now, nRT. So integral 1 by V into dV, 1 by V into dV, V1 to V2. Clear? So therefore here what you will get it now? nRT. So integral of this one, that is nothing but log base E. So therefore it is V1 to V2. So you can substitute upper limit minus lower limit. So log A minus log B, that is nothing but log A by B. So you can rewrite it as nRT into log base E, therefore that is V2 by V1. Base E we will not use much more times, no. So we will convert into base 10, no. So here you can write it as 2.303, therefore nRT into log base 10 of V2 by V1, final volume by initial volume. Even we can write down Boyle's law. What is the equation now? P1 V1 is equals to P2 V2. Therefore, here P1 by P2 is equals to V2 by V1. So you can rewrite it as one more formula here, no? That is 2.303 nRT into log base 10. Therefore, P1 by P2. This is your amount of work done in the isothermal process. This is equal to area under isotherm curve. That is here. This is one isotherm curve is there, no. So the area under this one, no, the area under this is nothing but whatever we derived. So this it will be the area, or this it will be the work done. Clear? So one more important point in our isothermal process, that is isothermal bulk modulus. Bulk modulus, that is isothermal bulk modulus, right? What is this isothermal bulk modulus now? Bulk modulus, you know the formula, that is B is equals to P by, therefore del V by V minus. This is your P by, therefore volume strain. So we can rewrite it as, therefore again PV is equals to constant. You can differentiate it now. Therefore, so P into dV plus V into dP is equals to 0. So taken here now. Therefore, P into dV is equals to minus V into dP. So therefore, here you can write down dP. Therefore, so here, so dP is equals to minus V into dP by dV. What you can write it now? Minus dP. This V I can take it down. dV by V. So this is nothing but your isothermal bulk modulus. Isothermal bulk modulus is nothing but the pressure of the gas at that situation, no. Therefore that it will give us like a isothermal bulk modulus. Clear? Important, very important, that is adiabatic process. So what is this adiabatic process now? Adiabatic process is nothing but right, you might have studied. So adiabatic process, here Q will be remains constant, therefore heat will not be able to exchange, or change in heat energy should be equal to 0. Clear? Heat energy should be 0. So what should be the specific heat now? Specific heat should be equal to delta Q by N into delta T. So it will be equal to 0. That means specific heat for adiabatic process should be equal to 0. That means a substance you have to take it, no, where specific heat is 0. That means without any supplying any energy, it should be getting heated up. Like that, I quickly get heated up, no. So that type of specific heat, no, is required for our adiabatic process. And heat should be constant. So it should not be able to lose the heat. It should not be able to gain the heat, no. That means it should be compulsory very quick process now. It should be very quick process. Clear? Right. Adiabatic process is a quick process now. Now, what is the first law of thermodynamics now we can apply in adiabatic process? So delta Q is equals to delta U plus delta W. So this is equal to 0. So therefore, delta W is equals to minus delta U. So what does it mean now here? So here heat energy we are not supplying, no, but work done, we are doing the work done. Therefore, it is changing the internal energy. That means sometimes the questions can come without supplying any heat. Can you increase the temperature of the gas? Or without extracting the heat, can you decrease the temperature of the gas? Yes, it is possible. So that is only by doing the work. So here how to do this work now? See here how this temperature will change onto this. Suppose if you are doing the work done, therefore, so work is done on the gas. Work done on the gas. Work done on the gas. On the gas means what you are doing now? We are compressing the gas. Correct? So we are compressing. Right? So compressing. That means volume is decreasing. So work done is how much now? Work done is negative. If you substitute negative, negative, therefore internal energy what will happen now? It will become positive. Internal energy positive means what will happen now? Temperature will increase. So when you do the work on the gas, therefore temperature will be increased onto this. Suppose if you are work done by the gas, work done by the gas. What is work done by the gas now? Work done by the gas. That means so it is by the gas. Gas is expanding. Therefore, here expansion takes place now. Clear? So when expansion takes place, what will happen now? Work done is positive. So work done is positive means what will happen now? Internal energy will be negative. When internal energy is negative, temperature will be decreased. Right? So that means if it is sudden expansion is taken place, no, quick process. Adiabatic process is a quick process. Suddenly expanding, no, therefore temperature will fall. So therefore sudden compression is taken place, no, temperature will be increased. Right? So you can see one adiabatic process now very quickly in our day-to-day life. No, see if you blow the air, therefore if you blow the air, therefore from our body hot air will become. You feel warm, right? So but if you blow the air like this, you try to see that. Therefore here you feel it as very cool if you blow the air, right? You try to check out, no. So if you are feeling cool, why? Therefore through the small nozzle the air is coming out. Therefore once it comes out to the atmospheric pressure, so lot of amount of free place is there, suddenly expands onto this, temperature is going to drop. Same air is coming from our mouth, no, that is nothing but a same temperature, but through the small nozzle, so therefore temperature is dropping. This is nothing but a adiabatic process now. Our refrigerators, our ACs and all this one, no, these are going to work based on the adiabatic process only. Clear? So now we will calculate the work done in adiabatic process. Work done in adiabatic process. Right? So we already studied, therefore delta W is equals to delta U. So minus delta U is nothing but NCV into delta T. Clear? So therefore minus NCV is nothing but R into delta T by gamma minus 1. So delta T means nothing but minus NR into T final minus T initial by gamma minus 1. Clear? So minus you can take it onto this. So NR T initial minus NR T final by gamma minus 1. So this NR T final means P initial V initial, so minus P final V final by so gamma minus 1. So this it will be your work done by the adiabatic process now. Clear? In this way we can calculate the adiabatic process work done onto this. Now most important part now, that is equation of the state, right? So what is the equation now? Right, here you can see PV to the power of gamma is equals to constant. This is your adiabatic process constant, equation now. We know the gamma value already we know it, that is nothing but Cp by Cv, that you can write on 1 plus 2 by F. This is F is what? Degrees of freedom. Gamma values also we calculated in our kinetic theory of gases part 3. So please check out all these values. So I already clearly explained about this degrees of freedom, gamma, Cp, Cv, all these one now. Clear? Now here we can write down one more equation here now. So P V relation here now. Now we will write down PT relation. PV is equals to nRT. PT relation. V I don't want. Therefore V is equals to nRT by therefore P. I will substitute here now. P already is there. So in the place of V I will write down. So nR is constant, no? T to the power of gamma by P to the power of gamma is equals to constant. So therefore, p to the power of 1 minus gamma, t to the power of gamma is equals to constant. Clear? So this is our one more equation in adiabatic process. So one more equation we can write it now. Pt, Pv, therefore now Vt we can write down, Vt. So how we can write down? We don't want P here. P, therefore P is equals to nRT by V. So nRT, therefore in the place of P I can write down T by V into V to the power of gamma is equals to constant. So what I can write down? T into V to the power of gamma minus 1 is equals to constant. So most of the times now the questions are asked based on these three equations only. So also you should know what is the gamma value for monoatomic gas, diatomic gas and all this one now. Clear? Right? So based on these three only most of the times now questions are coming in our competitive examination now. So we'll see that questions, right? So here we'll see one more graph now. Therefore PV to the power of gamma is equals to constant. What you can write it now? P is inversely proportional to V to the power of gamma. Clear? So how the graph it will be there now? How this P and V its variation now? So therefore here P and V, therefore it will be like a inversely proportional. Suppose here this graph is also looks like a isothermal now, right? So but what should be the difference? We'll see that now. Before that we'll calculate what is the slope here now? Slope is nothing but a dp by dv. Just now we calculated for this one. No? You do the differentiation, no? You will get it as minus gamma p by v. Clear? So sometimes they will ask, slope of adiabatic curve by slope of isothermal curve. So it will be equal to, if you write an adiabatic curve is nothing but a gamma p by v. So this is minus p by v. This is nothing but a gamma. Clear? So one more important formula we can rewrite it as like adiabatic bulk modulus. How to do it now? Just now in isothermal process I did know PV constant, no? Like that only, just to do the differentiation, no? You will get one more equation here, no? So that is, right? So bulk modulus, therefore adiabatic bulk modulus. Just now in therefore I calculated in isothermal process in this video only. Please check out. In that PV I did know. Therefore here PV to the power of gamma, exactly the same. Just a simple mathematics, no? You can get it, no? So gamma into P. Therefore here also we can write down one more equation, no? That is bulk modulus adiabatic by bulk modulus of isothermal. If you find this ratio, also you will get the gamma. This type of questions, no, frequently asked in the examination. Now, so you know that slope of adiabatic curve is greater, slope of adiabatic curve is greater than slope of isothermal curve. Now. So by seeing this slope only, we can identify whether it is a isothermal process or adiabatic process. What are they now? Let us see. We will see one simple question now. So here there is this is PV. Here two graphs are there now. One graph is like this, another graph is like this, right? So this is an expansion now. So here it will be, suppose it is V, so here it will be, therefore it is V2, V1, right? So can you tell me which one is isothermal and which one is adiabatic now? So here how to calculate it now? Simple thing, slope of adiabatic curve is greater compared to the slope of isothermal curve. That means which is having more steepness, that is adiabatic, which is having less steepness, that is nothing but isothermal. Here it is more steepness is there. So first one is adiabatic, so second one is isothermal. Similarly, similar type of question now. So we will see here now. Right, here P, here V. So suppose between two volumes, no? So we will see different. No? So one graph is like this, this is V2, this is V1. Another graph is like this. This is 1, this is 2. Another graph is like this. This is third graph. Now can you able to identify which one is isothermal, which is adiabatic, which is different one? See here. So here more steepness which is there now. This is 3. So 3 is adiabatic. So second one is isothermal. Therefore first one is water. Therefore here constant pressure is there. Volume is changing. First one is nothing but pressure is constant. That means isobaric process. Clear? So like this you can able to identify. Clear? So these are the 4 different process. One is isothermal, adiabatic, and isobaric, isochoric. So from these 4 process now you can expect the questions in the examination now. Right? We'll see some more concepts, no? Some more problems, no? See, in all the 4 process we already discussed what are the isothermal, adiabatic, isochoric, isobaric process, no? In all this one, which one will be having greater slope and least slope. So in this one now, therefore so here let us see, this is right here pressure and this is volume. So what you can write it now? Here if the graph is like this, this graph is like this now. Therefore what you can write it now? Volume constant here. So volume constant means what? This is nothing but a isochoric process. Isochoric, therefore slope it will be how much now? Slope will be infinite. So therefore slope is infinite. Clear? Slope is infinite. Similarly, so just now we drawn for adiabatic process, no? Therefore this is P and V. So therefore here the graph is there. So this is nothing but adiabatic. So slope what you can write it now? This is adiabatic. What is the slope here written now? Slope is equals to therefore gamma into P by V minus. Okay. So here similarly this is P and V. So you can write it now. This is nothing but isothermal. So slope is equals to how much now? Slope is equals to therefore P by V, negative, right? So next another one more graph is there. So this graph P and V. So this is nothing but isobaric. What is isobaric now? Slope it will be equal to 0. Therefore this is the order. So slope of isochoric graph slope is greater than therefore adiabatic compared to isothermal compared to isobaric. So these are the slope variations onto this one, no? Among this, so isochoric process will be having greatest slope of the PV curve. Okay, so one more concept, no? Right? We'll draw the graphs PV graph, PT graph, VT graph for all the process onto this one. So let us see. So first PV graph will draw. PV graphs. This is P, this is V. Just now we drawn, no? All these graphs are comes under like a PV graph. Suppose this graph. Can you tell me what is this graph? No? This is nothing but a pressure is constant. So pressure is constant means this is isobaric. Next one is, so this is your this is isochoric. Clear? Next one, so P is inversely proportional to this one, no? So therefore what you can write in now here, there will be a one graph will be there. This is nothing but a isothermal. Next one more graph it will be there now, that is this is adiabatic. So like this, so these are the graphs for PV graph, all these 4 process now. Now we'll go for another one more PT graphs. Here PT graph, PT. So what is the graph here now? So this is PT, P is constant, no? Therefore here, so isobaric. Now this graph, this is temperature is constant, no? This is isothermal. Clear? So next one is P and T, volume is constant, no? So therefore it will, the graph is like this. We use another color. If the graph is like this is, so what you can write it now, volume is constant, no? This is nothing but a isochoric. Clear? So now adiabatic process. So P and T, how the relation is there, no? P to the power of 1 minus gamma and T to the power of gamma is equals to constant. So P is inversely proportional to, so you can write down T to the power of gamma by 1 minus gamma. Therefore, the graph it will be, so here it is like inversely proportional onto this one, no? Here 1 minus gamma, therefore here the graph, okay. So we'll take it like this. Therefore here there will be a, this is adiabatic. So here this is V and T graph. So what you can write it now here, so therefore here it is constant, therefore volume is constant, therefore isochoric. If the graph is like this is nothing but a isothermal. Clear? So one more graph is there, no? Therefore here so this is P, it is straight line, no? Means pressure is constant, isobaric. Clear? So here about adiabatic, no? Therefore VT graph, no? So what will be the formula here, no? T into, so V to the power of gamma minus 1, right? So T is inversely proportional to V to the power of gamma minus 1. It is like inversely proportionality graph. Clear? So therefore the graph it will be, this is your adiabatic. Clear? So like this different graphs, no, for all different process, no. So you may expect this type of concepts now. Clear? So we'll do and also about reversible process and irreversible process. Very simple one, no. Reversible process means what will happen now? If you are making like one process, no, we are reversing in the same situation, no. So therefore total all the parameters should be returns to the same. Therefore nothing should be changed. Therefore there should not be loss of temperature, there should not be gain in the heat energy, final state. So initial state and final state should be the same. So that type of state we can call it as like a reversible process. Exactly opposite to that, that is irreversible process. So reversible process are very slow process, no. So irreversible process we can have like a faster process now, because there is a loss of parameter, loss of energy, loss of temperature, or I mean some gain in temperature, it will take place on this. Clear? And also about second law of thermodynamics. What is the second law of thermodynamics now? See, you know that what is the defects of our first law of thermodynamics? First law of thermodynamics, it will tell that law of conservation of energy, that means total energy initial, total energy final, it will be the same, but from where to where the heat energy is flowing, that was not explained by the first law of thermodynamics. So therefore here in the second law of thermodynamics, no, so we know that generally the heat will flow from hot body to the cold body. If you want to make the heat to flow from cold body to hot body, we have to do external work. So this only we can call it as second law of thermodynamics now. And also so many other ways also is there. If you give certain amount of heat energy, that entire heat energy cannot be converted into like a work done. So like 100% efficiency is not at all possible, no. So these statements are comes under like a, so second law of thermodynamics now. Clear? So we'll do one more part of this one, no? Part on the thermodynamics. So we'll do all numerical questions, no? Mostly all different varieties of questions, no? We'll solve on this thermodynamics now, right? So thank you. So please subscribe to my channel. So follow my channel. Thank you, students. Thank you for watching my video.